Also.
Yes.
You guys need the Zoom link.
I can Teams it to them.
Oh, perfect. All right. So I just made you co-host.
Okay.
Actually, no, I'm just making time out.
Napkins, I haven't do a register.
I just sent it in Teams.
So you are live right now, but I don't
We should
think.
wait a few minutes.
Anyone
I think,
have to?
yeah, MIT students are very crafty.
Yeah.
And should I keep my audio on?
You should
So
keep your
yeah,
audio
yeah.
on. I'm completely muted. So it shows all yours basically.
Right. Hey, everybody. Thank you for joining. We're very excited to be here. I am Dean Andrews from InterSystems, and I have Tom Dyer and Kai Chan with me as well. And we are going to walk you through the InterSystems Challenge for HackMIT 2023. Just a quick note, InterSystems is headquartered just up the road, One Memorial Drive, and we regularly sponsor both HackMIT and also MIT Grand Hack earlier in the year. This is the QR code for our resource page for our challenge for this hackathon this coming weekend. We also want you to know that in addition to this right here, we are also having a workshop, on Saturday in the morning. And then we will have mentors online 24 hours from Saturday to Sunday to help you with any technical challenges with our challenge. And then in addition to the big MIT Hack prizes, if you do our challenge, you have the opportunity for these additional prizes. So this is awarded just by us, and you can team up challenges. So if your challenge applies to more than one thing, you can have the opportunity to win prizes in multiple places. Here's a quick agenda for what we're going to go through. I'm going to tell you just a little bit about our company and our technology, and then I will pass it off to Tom to talk about our integrated machine learning, and to Kai to talk about our supply chain challenge. And slightly differently from our previous years with HackMIT, you actually have two options for our challenge. You can either do something with our integrated machine learning technology, or if you're up for a challenge, you can explore our new supply chain technology. And again, you can apply it to the sustainability track, for example, because it's all supply chain logistics, fits very nicely into supply chain. One thing I want you all to know that we really focus on empowering innovation. That is one of our missions. It's one of my missions as head of developer relations at InterSystems. And the way we do that is through our technology, also our expertise. We have experts in data platform technology and in specialty industries like healthcare, financial services, and supply chain, and we can advise. And then we also have a whole startup program where we actually nurture and support startups. I won't talk too much about it today, but you can always reach out to me, and I will be at the hackathon all weekend, and you can speak to me there. But just to show you kind of the vision of it, is that we support startups all the way along their journey from idea to incubation and acceleration, all the way to market. And just to give you a sense of this, the winner of our challenge at MIT Grand Hack last year is now in our startup incubator and has the opportunity to go all the way to market support. And we have incubation and acceleration, we have growth toolkits for startups, and we have a venture fund. We invest in startups as well. But without further ado, let me tell you just a little bit about InterSystems. We are a global company. We are a technology company. What we produce is a data platform. It is a very sophisticated and powerful data platform. It is a platform that you can leverage with your own applications and solutions, and you can take advantage of our ability to integrate and interoperate with other data sources, manage data, and then even analyze that data with AI, generative AI, machine learning, and other things. We have three core customer base domains: healthcare, financial services, and supply chain, but our platform is used around the world for a variety of things, including one that I'll mention is the European Space Agency maps the stars on InterSystems technology. But to give you a sense, in healthcare alone, we have customers in over 100 countries. Over 1 billion patient records are managed on InterSystems all the time, every day. And about 2/3 of the patient records in the United States are managed on InterSystems technology. Again, just in healthcare, just trying to give you a sense, this is a small snapshot. It is not at all exhaustive, but just to give you a sense, in healthcare, we work with stakeholders across the industry in healthcare. There are health systems and health providers that use InterSystems technology, insurance companies called payers, life sciences and medical device companies use us, regional health information entities called health information exchanges use us, and even government systems around the world, including the Veterans Administration, uses InterSystems technology to process all veteran health data, and the National Health Service in the UK is running on InterSystems technology. And again, that's just in healthcare. We also have a large footprint in financial services and supply chain as well. A little about our technology. Tom and Kai will be explaining more as they talk about our challenge, but I'll just give you a very brief overview. It is a platform. We've been in business for 45 years. We've been innovating, enhancing, and building on this technology all of that time. The core pillars of it are data management, data interoperability, and analytics. It is super flexible, the platform. It can be deployed in any way that you can imagine. It can be on premises for some highly secure environments in hospitals or banks. It can be deployed in any cloud service. It can be deployed as a managed service where we run the technology and you take advantage of it with your solution, or you can manage the whole thing. This is just a sample. Again, I'm using healthcare just as an illustrative way, but you don't have to think of it that way when you take on our challenge. But one of the special features that I mentioned that we're building special features all the time, this is our out-of-the-box interoperability. There are many data standards used in healthcare. There's FHIR, HL7, and X12, many others. And what we've built is out-of-the-box adapters where you can literally drag and drop and transform from one standard to another with low-code, no-code environment. You can also build custom interoperability elements if you need to, but this is all out of the box. So you can load our system, you can take an incoming data stream, perform business logic on it, transform it, and then send it out to anything you want, including your own applications. Again, in that flexible deployment, we are building a smart data fabric architecture. So you don't need the whole platform. Again, it's very sophisticated and powerful, has many, many aspects to it, but you don't need to worry about it all because you can simply take advantage of what you need. If you're just trying to integrate with something, you can access that integration service in the cloud, make an integration, spend all of your time and energy on your solution and not worry about the data pipeline, and we'll manage that piece. And then if you were a startup or growing a business, you want to add functionalities, transformations, machine learning, analysis, anything else, you could simply add those elements in a composable way. So it's very flexible, and we're helping many, many companies with their data pipeline. I will just show this as a segue, again, constantly building and adding. So this is a fairly recent feature. It's called integrated machine learning. Tom is about to tell you all about it, but just as a very quick summary, what it does is make machine learning and predictions on data very, very easy. Even if you don't have a background in data science, we've made this process very easy. And at HackMIT last year, we had many teams that were making predictions on data in 24 hours using this technology. With that, I will pass it over to Tom. Should I shut off the camera and you?
I'm just gonna plug in.
Okay.
Is that possible?
Well, we're on the Zoom.
And then I'm on.
Oh, you're on the Zoom too.
Yeah.
Oh, okay. Okay. Yeah. So here.
Okay. You'll let me sit down?
Yes.
Perfect. Well, I guess if you didn't hear anything, the punchline is that that integrated ML just allows you to get access to predictions, training your machine learning models, using those machine learning models right in SQL. So we've added some very simple SQL constructs, and you can see here where I'm actually using SQL. So a select statement, which means just get data. And then I'm getting it from this table, which I've used I have some yellow taxi trip data that I've developed a machine learning model, and I've called that machine learning model tip model. And what it was trained to do was use all the data in the table, all the other columns in the table to predict the amount of the tip for each ride. And so that you could imagine if you're looking at taxi data, you've got you're running a taxi service or something related to taxis. You have a bunch of data about rides, and now you can predict based on some information about a ride, how much the tip is going to be. Maybe you want to tell the driver this is going to be a crappy tip, or whatever it is that you want to do with this prediction. But this is how you actually use it. And this cloud portal gives you a whole interface where you can actually kind of play around with your predictions. When you execute that, it gets the table, it only gets the top 100 rows as you're seeing here, and then integrates right into the result set what the prediction is, and then you can see what the tip amount was. And this is data that the machine learning algorithm did not see. So that's another aspect, is when you're really using SQL, you can manage your data, manage your training and test sets with tables and views and all the power of SQL. You have all of that built in, and then just kind of adding on this little bit of machine learning magic. And then what you could see in the other parts of the interface is an actual kind of click through of actually creating the model, giving you inputs. You just tell it what you want to create on, train the model. It takes a few minutes usually, depends on how much data, of course. And then when you validate the model, and I'll go through these a little bit, but this is just a really quick way that you can see that it's pretty much a guided experience. So to get to that point, of course, you have to first create an account. And so for this hackathon, as opposed to previous ones, we're actually allowing you to get a full account. You don't have to actually email me, which the instructions might say on the link that we have. So there's some things happening. So once you make this account, you start a trial. So we have this set up so that there are kind of multiple products that people can get access to. And in this case, you'll have access to this Iris Cloud SQL, which has the integrated ML, and you just click start trial. You see the terms and you get a month free. So this is really nice. So then once you've signed up, and now you can look and see you have an account. There's actually documentation about the portal. So, it's a really nice professional setup. Let me see if I can move this stupid thing. Yeah. Sorry about that. Okay. So then you have your account. And then once you have an account, you want to create deployments. And so the one thing to think about here is that you have to click integrated ML because that's the machine learning part. It's not automatic. And then you can choose from all these different sizes of machines. Essentially, we're going to spin you up a machine in our Kubernetes cluster and install the data platform. And we give you these kinds of machine types. You can start small, but we wanted to give people access to enough data that you can do something serious. 500 gigs of tabular data is quite a bit of data. So that's what you do. You want to, when you're creating this deployment, you want to enable external connections, because that's the way when you're building an application, this is something sitting in the cloud. So you want to connect to it with whatever stack you're building your application on, it'd be Flask or whatever. You're going to want to connect to it. You choose a password, and then boom, you create that deployment. So I've already created. Oh, no, I haven't created one in this account. Let me go on to the next account. Okay, so I've created one here. You can see all the deployments that you create. So you can create multiple ones, I do believe. And you get the information about how to connect to it. And then you also can see this guided documentation on all of the things about how to actually create the model and then walk through the user interface. So the next step, of course, is to get data into your deployment. So you create this, and then it's just an empty database, essentially. So you go to, we have a bunch of data tools. You can import files. Let's see, import files. Trying to see where we had those. Oh, actually, add and manage files is the first step. So we actually have a bunch of built-in ones, and this is found from external transfer. You go to external transfer, and you could add your own storage. This is where you would connect to maybe your own bucket. And then we show you how to actually connect your S3 bucket, because this is running on Amazon, by the way. And so you can use S3 buckets. And then once you do that, it'll list the files, and then you can just select all these files. In this case, we have example files for different data sets. And this one that I'm using are these yellow trip data sets. We have the SQL, which just creates the tables, because that's a kind of an aspect of using a SQL database. If you haven't already, first you create the data tables, and then you actually import these CSV files. But that's after, of course, you transfer all that into your deployment. So then you have those files and you import the data from those files into the actual database. And this is all guided through here. We have our own InterSystems syntax. It's this yellow data, makes the table. And so that's very straightforward and simple. So then after you've created those tables, you got your data in there, then you can create the model. And this is where the machine learning stuff starts. In this case, you just have a model name, which I had made tip model before. And so I can make tip model 2. And then you just tell it which table to train on because, well, in this case, we want to train on the train table. And you tell it which field to predict because you have to have one of those fields is one that you're actually trying to build your machine learning model to do predictions on. And so in this case, you just choose that, create model, and then it's created. There's really no work done there. The real work is done in the train. So then you choose which model you're training and you can name it separately. That's just so you can kind of manage the names. And when you have multiple models, you might want to name them. It's really an advanced kind of thing you don't need to worry about. You just click train and then it'll show you keep track of the training, keep updating. So this one completed before, but this one is just starting now. You can see the log. Well, it just started, not much happened. I think in this one, see what the log, oh, well, okay. So maybe our log isn't all that helpful, but it just happened so quickly that there was no issue. So it's a good thing. But then you can see after you train it, you see all the trained models, you can get some information about them. You can see what the name of the model was when it was trained, yada, yada. So it's kind of like an MLOps light kind of experience. You've got your models that you can see. And when you validate the model, it's interesting, is that you test it. Validation is testing it on data it hasn't seen before. And so in this case, we have a separate data table that's set up for validation. That was what I showed initially at the beginning of this. Gotta take out the garbage. Damn it. Damn it. Forgot. And then you can just hit validate model. It runs the model on that data and calculates some statistics. It doesn't take very long at all because it's pretty small things, and you can just see the validation metrics. And in this case, you can just see some types of information that will be useful. RMSE of 0.6, it's not the best, but the R squared is pretty good. And we give you a little chart just to kind of give you an overview of how the data looks, the predicted versus the actual. But this is just kind of a lightweight type of thing to get an overview of what you have going on. Then once you're done, you could then go back if you didn't like the numbers and the performance didn't look good. Maybe you just try it out in your application. It doesn't look good. You can go back and do some feature engineering or whatnot, change the data, maybe clean up the data, because what we've seen in a lot of hackathons, people will take some data from the internet and just think it's ready to use, but you have to really sometimes dig in and look and see there's a lot of maybe missing data or bad values and things like that. Do some basic data cleaning. You can go back and train, and then once you're happy, you can then start really using it, just like I showed in that predict. So, so I hope that that was kind of a whirlwind tour of what integrated ML can do. It's really for classification and regression. This is not a chat GPT thing. We don't really have stuff for really sophisticated text analysis, but if you do have text fields, we do some basic feature engineering. So it can work relatively well on text data. It's just not chat GPT level of really giving you a prediction based on web scale data. Nevertheless, works pretty well. And other than that, you just have to worry about kind of your resources and how big your data is, and maybe go to a larger instance size and start back over again with the deployment. So it's really pretty darn easy to get started. We have really good documentation as well, and we're going to be around all weekend and all week. So hopefully you guys will be able to take advantage of this. So any questions? Real quick. Well, we can get back to it after Kai goes as well, but. And I wanted to also mention, so Caius is going to talk about a slightly different, the supply chain product. And within the supply chain product, it's built on top of our data platform, which includes integrated ML. So you could actually mix and match the integrated ML with the supply chain concepts and that data model. And that would be really interesting and really creative. And we'd love to see what people do with it. So thank you very much.
I think we actually have one question from the live stream.
Okay.
Someone's asking, and this is not necessarily about the product itself, but
yeah,
like overall about the entire pipeline. But one's asking, where's a good place to find data sets online to use with integrated ML?
So I think Kaggle is probably the best place to find data sets online to use with any kind of machine learning. And then there's the big UCI, data sets. But those are the Kaggle seems to have like the best to me. So great. All right. So I will stop sharing. And so you're going to use your laptop? Or?
Supposed to use these not machines.
Share screen. On screen. Share. All right. Okay. Let's get started. My name is Kai Chan. I am the solution architect for the supply chain product at InterSystems, and I'm also an MIT alum, class of ancient time. All right, last century. So for agenda today, want to get you guys, number one, to get excited about supply chain. It doesn't sound too glamorous, but it's actually very, very important. And we want to introduce you to the InterSystems Supply Chain Orchestrator, which is built on top of the technologies that Dean has so eloquently described, and it's nice, cool technology. And tell you how to participate in our supply chain challenge this weekend, and give you some ideas to get your creative juices started. And then at the end, I'll save some time for you to ask questions for all three of us, not just to me. Wait. How come I escaped out? Come on. Start slideshow. Yep. All right. Why am I get kicked out of the slideshow? Okay, doesn't matter. You guys can see my screen anyway. Good enough, big enough. All right. So why supply chain? Number one, because we need it. And everybody need to eat. Your food comes from supply chain. Everything in this room comes from supply chain somewhere. So the global economy depends on it. We learned in the last few years what happened when supply chain fails. You know, when the pandemic started, we didn't have enough masks to go around. People die because supply chain fails. Prices of goods goes up because supply chain fails, and bad things happen. And supply chain management is becoming big business. So it's predicted to, in 2020, is $20 billion to manage supply chain, not the wealth of the goods traveling through the supply chain. It's just the management of the supply chain is $20 billion business. And in the next 10 years, it's going to be more than double. And then, but we are better than that. You know, we want to save the world. And remember, you know, one of the tracks in this hackathon is the sustainability track, and supply chain is very intimately tied to how sustainable our economy is. Just give an example. Just look at the trucks on the highway. If we just route the truck efficiently, and I'm going to talk about that later. If we just use the truck efficiently and make sure that they are not empty and they carry goods from point A to point B efficiently, it's talking about $7 billion of diesel every year. You come to how many tons of greenhouse gas there? $7 billion of diesel. So, you know, smarter supply chain is going to make a smarter economy, is going to make and other industries to become smarter. So it's a beginning point. Okay, so the next we go to the InterSystems supply chain orchestrator. This is the product. Is compared to the other product, InterSystems, as Dean said, is a 45-year-old company. We have 45 years experience of building, you know, really good data platform. Supply chain as a product, orchestrated as a product, is 4.5 months old, maybe less, 3.5 months old. We have been working on supply chain, but we officially call it a product only in June. So 3 months old. And did we have supply chain experience as a company in the system? Yes, we have been doing supply chain, but we don't call it a product. We officially make the first release of the product 3 months ago. So what we want to do, move the bar away, to provide the next generation data platform and key supply chain service for building supply chain solution with real-time intelligence. Things are fast, things are real-time. with predictive and prescriptive actionable insights. Just that integration ML, integrated machine learning for things like that, and AI optimization and all those things. And it become a connective tissue for integrating disparate data sources. Something that I always emphasize is data works better when they are together. And we bring data together as, we call it now the data fabric. We interoperate with different systems. We make it easier to put everything together. All right. So this is the InterSystems supply chain orchestrator. We have two parts. We have services and we have the core product, the InterSystem Iris for supply chain. The blue boxes are things that we built on top that are useful, that are client specific. And then the basic framework that everything depends on is on the blue box. We call it Iris for supply chain. In this hackathon, you're not given the blue box. You're given the green. No, they're not given the green box. You're given the blue box. And you're going to build things that's supposedly going to be in the green box. Okay, and what's in the blue box? Well, it's the data fabric. It has all the elements of the data fabric in it. So it is capable of ingesting data. It is capable of storing data. It is capable of analyzing data in a predictive and prescriptive way. It has ML built in. It has AI built in. It is very powerful. So if you're a business person, oops, sorry. If you're a business person, you have a you begin on the left-hand side, you gather data, and then you analyze the data, build KPIs, and then use machine learning to analyze the data, get the risk factor, or get the KPIs, or get the predicting what's going on, and then we analyze the business and then generate actions. So from left to right, you start from raw data and you bring into predictive analysis and prescriptive analysis. It tells you what's supposed to do. Okay, so that is business talk. You are not business person. I'm not business person. Let's talk about technology. Okay, so what's in the box? We are literally going to give you a box. It's going to be, in this hackathon, it's going to be a Docker container. Literally, it's a container, it's a box. And in this box, we will have a data platform, a database that with a framework for supply chain, meaning that you have a schema, you have API, you have things like that. And when you look at it, it's like, oh, it looks so simple. It's simple for a reason, because it's very flexible. So if you are looking for something and you don't have it, you can build it. So we have the basic things, what's a product, what's a route, which is what's a purchase order, we have a product order, we have an inventory description, we have all those things. So those are the basic supply chain elements, and we have tables and we have data model for all of them. But you most likely are not going to have everything you need to build a report. But we are flexible. How flexible we are? You can create custom objects in this system without writing code. So InterSystems, the Iris platform, has our own proprietary language called ObjectScript. You're not going to learn ObjectScript in 24 hours, but you don't have to. You can just call the API and use your standard JSON object, post it with your favorite client, REST client, and create new objects, custom object. You want a table to have a new field, call an API. It's all done. Okay. It has standard connectivity. The most useful you probably will see is REST API. If you want to use JDBC, we have JDBC connection. And since most of you are not going to learn object script in 24 hours, we support Python. And the Python is embedded Python, meaning that you are not running Python on a separate process. You're running it in the same memory space with the same process on the same CPU as the database. Which means that it is a first-class citizen. It will be fast. It will have direct access. And if you want your own Python, you can run your own Python and connect with REST. If you want direct access to the data with Python, you use embedded Python. As Tom just said, we have built-in analytics. All the things that Tom demoed is also available in this box. Integrated ML is available in this box. So you have a good set of tools for you to build something that's quite meaningful. So I will not have time to walk you through how to use every single thing. So for the hackathon, this is one place that you got to land. So we have a GitHub repo that you can put down. It will give you the credential. It gives you the location, the URL to download the entire Docker container onto your own machine. You can bring your own laptop, you can bring your own desktop. As long as it's run Docker, you are going. You can put it on a AWS EC2 instance. You can bring your own cloud platform. You can use anything machine. As long as you have Docker, you are set. We give you a license, which allows you to use this product for a week. And we give you some sample data. You can use sample data. You can download other data from the internet, or you generate your own data. But we have a small sample set just to get you started. And they will have the how-to documents. It will have links to our support system, so that if you want to learn how to use it, all the things I said, how to do embedded, how to make the REST call, how to change the schema, how to do all the things that I promised you can do. There are links and how-to documents for that on this. Before Saturday, before this weekend, these are the places where you can go to learn about this product. It's not considered cheating. You can get a head start. So we have our supply chain general information page. On it, you can get the technical documentation. You can get the RESTful interface API description. We actually have a learning path. We actually have demos and tutorials to help you build a supply chain product and a supply chain application in a learning path. It's a good thing to. So one thing InterSystems does really well is we have a very good learning environment. You can log in and learn about the system, learn how to program in the system, learn how to use the system. So I encourage you, if this is something that interests you, you can start right away. Okay, so the next part, I'm going to get you more excited about supply chains. These are all problems that are real, that we have attempting to solve. We solved in the past, and they are important problems for this world to have. But don't let what I talk here to limit your imagination. You can use your imagination. You can tackle other problems. I'm just giving a sample of problems. Okay. Problem sets number one, as I said, when a truck goes from point A to point B, delivering something, maybe you go from, warehouse to a store, it drop off the goods at the store, it goes back to the warehouse when it's going back, it's empty. Empty trucks still burn diesel. Empty trucks still require a driver. So it is a lot of resources that's wasted with trucks running empty on the highway. Now, if we have a system that rent out those empty trucks to carry stuff for some other company, for some other customers, then we save a whole bunch of diesel and a whole bunch of resources. So in the trucking industry, this is called the backhaul. So if you have a system that just analyze the demand and the truck route and figure out where the backhaul supply or backhaul capacity is, and where the demands are, and you mesh them together, you've done the trucking company a lot of business, you've done the environment a lot of good. So this is idea number one, backhaul. Idea number two, as I say, supply chain, we just gone through that. There are something in life that are important, that are critical. You don't want a hospital run out of masks. You don't want a hospital run out of drugs. You don't want a supermarket to run out of milk. Those are things that are critical. We don't want to run out. And how do we make sure it doesn't run out? Is to stockpile a large supply on the things that you think is critical. But what if those critical goods happen to be perishable? So you store up a lot of drugs so that in case there's some outbreak, you have the medication ready. But those medications get expired. It's a waste of money. The hospital look really bad because your healthcare bill is going to go up. You're throwing away drugs? Yes, they are, because they expire. Can you order less? No, you cannot, because if you order less, we may run out. So that is this dilemma. So how's the solution? The solution is to, same sentence, data works more efficiently when they're together. What if we look at all the different stockpiles and put them together? Now, if one stockpile is low, the other stockpile is high, we can transfer medicine from one stockpile to the other and avert the crisis. And if one stockpile have some drugs that's going to be expire, some goods that's going to expire, they can sell it for cheap to somewhere that's needed, right? So if we work together, we can provide very significant savings to overcome the variation in demand or the disruption in supply. We can manage the critical good better. Everybody lives better. And optimization, we go through optimization problems. Too much of something is not good, too little of something is not good, right? That's when you need to optimize something. Modern day supply chain, you have manufacturing, suppliers, warehouse, shipping, retail, online store, a whole chunk of things. At each location, we need to keep some inventory there. If we keep too much, it's going to be costly, it's going to be wasteful. If we keep too little, we may run out. So we have to find the optimal balance between too much or too little. The other thing that we optimize, and these are actually products that we are building or we have built in the past, okay? Factory have demands. Factories don't make only one product, they're making many products. Each products have different demands, they have different raw material, they need different amount of labor, they have different equipment, they need different storage, and you need to have the raw material shipped in, you have the finished product shipped out, And it has to, if you have the same assembly line making two different products, you have to retool the assembly line, you have to retrain the worker. So all these have to take into consideration. So the problem on optimizing a manufacturing site is given the demand, how are we going to make the product? Which product go first? Do we make more than the demand, less than the demand? Which product makes more money? Which product takes more critical raw material? And overall, how does the entire manufacturing plant be most efficient given the limited amount of labor, limited amount of raw material, limited amount of time on the assembly line? How do we make the most out of it? Optimization. And the last one I want to talk about is not a problem, but I would like every one of you, whenever you build something regarding a supply chain problem, always think of the resilience of the system you're building. Things do go wrong. In real life, things goes wrong. We just suffer through it. Last few years, things going wrong. So can we look at a supply chain model and identify how it will get wrong, identify the points of failures? Can we recover from failures, recover from disruptions? Can we predict if a disruption happens? Can we predict how bad it's going to be? Can we actually prepare for future disruption by building smarter supply chain, faster supply chain, or building more capacity or better distribution center? Can we prepare for disruption? Because we know disruption is going to come. MIT has a very big initiative on the global climate change. We all know this is happening. And with global climate change, we know we're going to have more hurricanes, we're going to have more floodings, we're going to have more forest fire. The world is just going to be a worse place to live in. So how will all these disruptions, weather events, be impacting the global and local supply chains? Can we build smarter supply chain to face the challenge? So this is not a project for you to build, but any project you build, since we are in the sustainability track, I want you to, get your mind wrapped around and get the best mind to make the smartest supply chain that can weather the storm quite literally in the future. All right, so thank you for your time. I hope I got you excited about this very important part of our economy. And now it's time for questions, not only for me, for Tom and for Dean. Yep.
Yeah, is this did it mock like a supply chain? Like I'm assuming that we're not actually connecting to the build.
You are not creating a mock supply chain. No, you're not connected to the real supply chain. We have the sample data are generated. They are not real, but they are enough for you to, make sure, oh yeah, whatever code I write is working. I'm pulling down real data from the data. And you can generate your own data set, and we will have instruction on how to upload your own data set. Or you can find publicly available real data. As we say, Haggle is a very good place to get real data, and I think they have supply chain related data, so you can get real data. You probably you can write emulator, say you can emulate a disruption in supply, or suddenly at the pandemic outbreak, how are your supplies of masks and PPE going to head on? Okay, so any other questions? Yep.
Yeah, I guess I have a question about, so the, like, the supply chains, there's like for the box, there's like API stuff.
Yeah.
Is there like something else similar for the like general integrated ML, like outside of like the supply chain?
So integrated ML is all SQL. So anything that you can totally access it via SQL.
Yep.
Yeah.
So so the API for it is SQL. So anywhere you get a JDBC connection and you can actually, so there are different ways to call it with SQL in that you don't have to have a table. You can just pass the numbers of an example. So like I was showing it predicting on a table that it hadn't seen before that had the same columns. And I'd say it had about 15 columns. Well, there's a way to call it in SQL where you just give those 15 numbers of some row or some example that doesn't exist in the database. So essentially that's like a model call. Like you're just calling the SQL, you're overriding the values that you want to pass it, and it'll give you the prediction back. So you can totally just treat it as it's just an API and it's just this thing, but the API is SQL. And then you have to use whatever SQL adapter or whatever that's getting that text back. So result sets will come back like in Python, it'll be like a data frame or whatnot. So yeah, it would be interesting to see how you use it. That's the basic idea.
Any questions? So we also have, as we say, we have a team of mentors online throughout the hackathon, ask questions,
We'll be there all weekend.
Yeah, we'll be there all weekend. All right, I think,
Good.
yep, finish the pizza.
Thank you so much.